Welcome to this video on the electrochemistry topic. We're going to be looking today at the electrochemical series. So we want to know what the electrochemical series is, to understand how it's linked to oxidizing and reducing power, and to understand why the series is useful. So let's begin. Now the electrochemical series, I've just shown you a part of it here, is a way of ordering redox equilibria by the standard electrode potentials. So typically we have the most negative potentials at the top here. It could vary, so make sure you check. It could be the most positive at the top, but usually it's done this way around at the bottom. So why is that actually useful? Well, it's useful because the position of a species in the series is linked to its oxidizing and reducing power. And in order to understand that, we need to remember that if you have a species which has a very negative standard electrode potential, that means that the equilibrium shifted, or the equilibrium position, is far to the left. Far to the left. Whereas the equilibrium position for these substances here is far to the right. Far to the right. So it favours the products of the forward reaction as written here. So in this equilibrium here, you've basically got exclusively fluoride ions, and in this equilibrium here, you'd have exclusively Li+ ions. So how is that actually linked to oxidizing and reducing power? Well, what that actually means here is that this substance here has the least tendency to gain an electron. In other words, the least tendency to be reduced. And therefore, it's the worst oxidizing agent. If you want to cause the oxidation of something, if you want to take electrons away from something, don't use Li+. It won't work for anything. In contrast, F2 has the greatest tendency to gain electrons. Tendency to gain electrons. So it's the best oxidizing agent. If you want to oxidize something, then fluorine will do it. Now let's think about the species on the other side here. So lithium here, the equilibrium is right over to the left. So lithium has the greatest tendency to lose electrons. So it is the best reducing agent. That doesn't mean that it's going to react the fastest, because cesium actually reacts slightly it reacts faster than lithium, but it is thermodynamically at least the best reducing agent. In contrast, fluoride ions are the worst reducing agent. So we've essentially got them with this series. If you're at the top of the series and on the left, then you've got here the best. Sorry, if you're at the in your bottom left of the series, you are the best oxidizing agent. And if you're in the top right of the series, as we've written it here, you are the best reducing agent on the right hand side. So that's how it's related to oxidizing and reducing power. Now, why is this series actually useful? Well, it gives us a really useful quick way to just see whether certain reactions are actually going to happen. So for example, imagine here we've got this situation where we've got H+ ions reacting with a couple of electrons and being reduced to form hydrogen gas. This is what is actually happening to H+ ions when an acid reacts with a metal, for example. Now you know that only certain reactive metals can do this, but now the electrochemical series allows us to put that on a quantitative footing and actually make some predictions without having to test the metal out. So copper appears here in the electrochemical series. Cu plus 0.34 volts. I don't need the volts because it's up there. Now what does this mean? Well, because copper has a more positive electrode potential than H+, what that essentially means is that if there are any electrons around, then the copper 2+ ions are just going to capture them and turn back into copper. So if it's below H+, H2 redox equilibrium, that means we won't reduce. So copper won't reduce H+ to form H2. What that means is that copper won't react with acids to liberate hydrogen, because it's below it in the reactivity series, below it in the electrochemical series. Now let's take nickel as an example here. So nickel Ni2 plus 2 electrons. This forms nickel, and that's actually at a negative 0.25 volts in this case. And now, because this equilibrium is further to the left, then what that means is that if some electrons were to emerge off the nickel, then actually H+ has a greater tendency to gain them than the Ni2+ does. And so when that nickel releases a couple of electrons and just ionizes, because these reactions are reversible in aqueous solution, then the H+ ions are going to be the one that take the electrons, hydrogen gas will be formed, that will bubble away and essentially make the reaction become irreversible, and so nickel we'd predict would react with H+ ions to form hydrogen gas. So it's above H+, H2, implying that it will reduce H+. So some thinking is needed, and that's what future videos will tackle, but the electrochemical series is a very quick way just to look at whether this will actually work. So for example, Fe3+ will react with fluorine, but for example nickel, if you react it with cesium+, it will not form cesium metal.